Okay, so today we're going to talk about solving systems by elimination. And our learning target is to be able to solve linear equations in two variables by elimination. Before we do that, let's do a little estimation. How many almonds are in this container? We'll pause here. Okay. So our essential question, how do I solve systems by using elimination? Before we do that, let's review a little bit about what opposites are. In math, we call those additive inverses if we're adding. You can have multiplicative inverses. We're going to talk about additive inverses. So if I'm thinking of 7, the inverse of that is -7, because when I add those together, I get 0. And same thing, if I have, let's say, -21, the inverse of that, or the opposite of that, is 21, because when I add those together, I get 0. Also, if I'm talking about something with a variable on it, like 5x, the inverse of that is -5x. Again, because when I add those together, I get 0. So these are called additive inverses. We're just going to say opposites for now. And because we add them together, we get the identity, the additive identity, 0. And so they would cancel each other out. Okay. We're going to use that fact along with some other properties that we have discussed in some previous learning this year. Okay, once again, we're trying to find where the lines intersect, if at all. Most of what we'll be looking at is exactly one solution. It is possible to run across no solution or infinitely many solutions as well. Okay, and we've discussed the first two, graphing to solve systems and substitution. Today we're going to get into elimination. Once again, when we're solving algebraically, we're trying to reduce the system to one equation and one variable. With substitution, we substitute it in so we could get one variable. With elimination, we're going to eliminate a variable to get there. Okay, elimination, this always sounds to me like an Arnold Schwarzenegger movie, so I just put that in here for a little fun. Okay, how do we solve systems by elimination? These are the steps. You want to use elimination when you see both equations are in standard form, which is ax plus by equals c. In other words, x and y are on the same side. Then you want to apply this. And then in order to get this to work out, you're probably going to have to multiply one or both of the equations. And really you want to try to get opposites of each other. And then you add them together. This should eliminate a variable and then solve for that variable. Then you'll substitute in to find the other variable and write it as an ordered pair. So let's see if you remember this a little bit. So here's a problem. You'll notice both in standard form. We're going to solve this using elimination. Now, you're trying to eliminate x or y. So you want to look at sort of just your x's first and say, are these opposites of each other? 10x and -5x. No, we'd want one to be like 10x and one to be -10x. So they're not opposites. How about these? Are these opposites? -12y and +3y. No. So we want them to be opposites. So I'm going to have to make them opposites. And in order to do that, I'll have to multiply one of the equations or maybe both of them. In this case, I'm going to decide to get rid of x. And in particular here, it doesn't really matter which one you get rid of. There's the same amount of work. So in order to do that, I want to make this bottom right here, this -5x, I want to make that -10x. So I'm going to have to multiply this by 2. And so in order for that to work, I've got to multiply the whole equation by 2. I can't just multiply just that first thing. So what I'm going to do then, is rewrite my equations. Okay, so let's do that here. The first one I'm just going to copy, and that's 10x minus 12y equals 16. And now we're going to multiply this whole bottom equation by 2. So I get negative 10x. Watch your signs. 2 times 3y is positive 6y. And then 2 times 1 is 2. Okay, now we're going to take these and we're going to add them together. So I put a plus sign and I put it in parentheses so it's not confused with any other signs that are in this problem. Okay, so now we're adding vertically here. 10x and negative 10x are opposites now, and they eliminate. That's the goal. That turns to be 0. This is why we call it elimination. Now negative 12y plus 6y is negative 6y. Again, be very careful with your signs here. And then you've got 16 plus 2, so 18. All right, now we're going to solve for y. Notice we have one equation with one variable, and we can solve. So now I'm going to divide by negative 6. And we get y equals negative 3. All right, great. Now what we need to do is we need to take this value here and we're going to plug it into one of these two original equations. It actually does not matter. Pick the one that looks better to you. I like the bottom one here because it's a little smaller numbers. It does not matter again though. So I'm going to say negative 5x plus 3 times. Now negative 3 is y. So that's going to go right in here. So I'm going to say negative 3 equals 1. Okay, so now I have a little bit of algebra to do here. Okay, that's negative 9. Add 9 to both sides. And we have negative 5x equals 10. Divide by negative 5. We get x equals negative 2. Now, when you're done, always write your answer as an ordered pair. So here we have, where do these two lines cross? They cross at the ordered pair, negative 2, comma, negative 3. Okay. Again, elimination, best to use when both equations are in standard form. All right, so hopefully that jogs your memory a little bit from Algebra 1. Let's take a look at one more. All right, so solving this system using elimination. Now, in this problem, you'll notice these are, I don't have any opposites here, and I don't have opposites here. If you did, you wouldn't have to multiply. You could just go ahead and add the two equations together and go from there. However, this one I'll have to multiply both equations by something to get opposites. So I think in this one, I'm gonna to be different. It would probably be easier to get rid of x here, but just to be different than the previous one, I'm gonna get rid of y. Okay, so what you wanna do is multiply both to get opposites. So I wanna say, what is the smallest number that both 8 and 10 go into? And that's gonna be 40. You could do 80, but then it's gonna be bigger. I'm gonna go with 40. So that means I need to multiply the top here. I'm going to multiply this by 5. That'll give me negative 40y. And the bottom by 4. Remember, one has to be positive and one has to be negative. It doesn't matter which one, but one positive, one negative, so that when you add them together, you get 0, right? They're inverses. So now if I do this, I'm going to write my two new equations. So that would be negative 20x minus 40y equals negative 60. Okay, and then the second one, 24x plus 40y equals 24. Now don't forget to multiply the last thing. This is what most people forget, so just be careful with that. You don't forget those last ones. Okay, now notice I do have opposites. When you do the multiplication, if you don't have opposites, you did something wrong. Okay, so now I'm going to add these together, right? So I got 4x, okay, and this would give me negative 36. All right, divide by 4, x equals negative 9. All right, now you're going to take and plug back in to one of the originals. I think I'm going to plug into, you might plug into the second one if it looks a little easier. I'm going to just do the first one, again, just to be different than the last time we went. So negative 4 times negative 9 minus 8y equals negative 12. Okay, so this is 36. Okay, be careful here. I need to get rid of that 36. It's a positive 36, so I'm going to subtract 36 from both sides. Now, here's where people will just bring down 8y. They forget about that negative sign in front. Make sure you bring that down as well. And this is negative 48. And then if I divide by negative 8 on both sides, right, we get y equals positive 6. So where do these cross? Negative 9, comma 6. That's elimination. Hopefully you remember this a bit. Okay, here again are the steps. If you need those and you want to put those into your assignment as a reference, or pause here and have it up, that's great. Okay, so your assignment is solving systems by elimination. Don't forget to write this into your planner for today. Okay, and that's it. Have a good one. See ya.